Hey, what's up guys? In today's video, I'm going to be doing another LeetCode daily video. It's just 4 p.m., so perfect timing. And also, I haven't been doing too many videos lately since I've been really busy. But yeah, let's get started. Holy, got another hard one? Why do we keep getting hard ones? Okay, this will be exciting then. The hard one for yesterday's daily was really hard. So Jump Game 4. I think I have seen Jump Game 2 before, but I haven't seen Jump Game 3. Given an array of integers array, you are initially positioned at the first index of the array. In one step, you can jump from index I to index I plus 1, where I plus 1 is less than length, I minus 1, where I minus 1 is greater than or equal to 0, and j, where array of I is equal to j, and I is not equal to j. Okay. Return the minimum number of steps to reach the last index. The minimum number of steps, so this is like maybe BFS. Notice that you cannot jump outside of the array at any time. Okay. Output is 3 because you start at 100 and you can jump to any other index that's 100. And then, so you jump straight to this 100. And then he decides to go to 3 because that's just one less. And it's not a negative number, so he's allowed to jump there. And then he jumps straight to the end. Here the starting index is the last index, don't need to jump. And here you can directly jump from 0 to 7, which is the last index. And it's 10 to the 4. Okay. Seems like a BFS question to me. So I just do a BFS implementation. I want to have the queue start off with the 0th index and 0 jumps in total. And then have a visit array with a set. And then visit.add of the first index while q.pop is equal to index comma the like how far I jumped, how many jumps is equal to q.pop. And then okay, I need to optimize this a little bit, but okay, I'll just do the optimization now. So I'll just create an edge array and do the optimization to determine all the different edges. So I can do from collections import default dict, and then edges equal to default dict of list, and then for I in array, I'm allowed to do n squared here, right? Does this number let me do n squared? I think I'm allowed to do n squared. Comma for I comma num in enumerates of the array, and for I2 n2 in enumerate of array. This is actually probably a worse. Okay, I'll just do for I in. That way I don't have to deal with I don't have to deal with this. Oops. Okay, there we go. I don't have to deal with duplicates. If array of I is equal to array of j, then edges of I dot append j array edges of j dot append I print edges. Let's just make sure this works. Maybe it's not called default dict. Okay, let me find the syntax for default dict. That's what I did? Oh no, I capitalized the thing on accident. Okay, guess there's no capitalization. Okay, 0 has 4, which makes sense. And 4 has 0, which makes sense. 1 has 2, which makes sense. Okay, I think it all makes sense. 2 has 1. I plus 1. Okay. Okay, and then now we can move on to this one. We can move on to this BFS. So ij is q dot pop, and then for I in edges, oops, not I, j in edges of I, if j not in visit, then q dot insert at 0 of j and jumps plus 1. And then I also need to insert the next point, which is I plus, oh, I need to check if it's in the thing too. If I plus 1 not in visit, q dot insert at 0 of I plus 1 of jumps plus 1, and then if I is equal to n minus 1, then return jumps. Let's see if this works. I'll put 4 when I expect 3. I'll put 0 when I expect 0. I'll put 1 when I expect 1. Okay, so I forgot to consider this case here. Definitely forgot to consider this case where you can go backwards as well. So let me just do that real quick. I minus 1 not in visit, and the array of I minus 1 is greater than or equal to 0, then I can do I minus 1s here and here. Okay. Easy. I think, hopefully I don't runtime exceed. That's the only way I can see this failing, is if I runtime exceed. Oh wait, I'm gonna runtime exceed. Oops. Because I forgot to update visit. Yeah, visit. How did I get wrong answer here? Visit of I is equal to visit.add I. Oops. Okay. Here I straight up just get the wrong answer. Let me just print I jumps real quick. Okay. 0, 0. Okay, let's just look at these numbers. 68 can jump to this 68, but it might not be worth it. Or I minus 1. Oh, I can always go I minus 1. I thought the number had to be less than 0. Okay, I just didn't read this part. I can always go as long as it's in range. And I plus 1 is n, and I minus 1 equal to 0. Oh, SMH, that was the only mistake. Okay. I actually time limit exceeded. Oh, frick. Okay. Just a very large chess case. Okay. I mean, just adding the jumps, just adding the edges is taking n squared. So it is not the issue with my BFS. It's literally just creating this edges takes n squared. And the BFS should only take like a slow n. So I can try to create the edges faster. I can do that by, if I sort with n log n, and then I can try to make the edges faster. How would I do that? How would I sort it? Okay, so if I had like 1, 2, 2, 3, 1, 3, 2, and I sorted it, then this would be index 1, 0, 1, 2, 3, 4, 5, 6, and I sorted it, it would be 1 and 0, 1 and 4, then 2 and 1, 2 and 2, 3, oh wait, and then 2 and 6, 3 and 3 and 3 and 5, and then I can put this into my edges. And then I can loop through and shove these two numbers into 1 and these two numbers into, these three numbers into 2, and then these two numbers into 3. Yeah, so I'm going to do that instead. So edges is going to be still a default dict. So I want 1 to link to 0 and 4. I want 2 to link to 1, 2, and 6. And I want 3 to link to 3 and 5. Yeah. Yeah. So we need a temp is equal to sorted. No, array dot sort. I think array dot sort will change it, so we can use sorted. Sorted of key is equal to lambda x, while x is just by the first term, or no. We want j comma I for I in enumerates, for I comma j in enumerates of array, key is equal to lambda of x of 0, print temp. Okay. Sorted list in Python. Can you do key like that? You can. Okay, let's put this in square brackets. I think I forgot to do. Okay, 23 and 1. Negative 23 and 1. This. Okay. And then all I need to do is for I in temp, and I need to create this edges thing again. List for I in temp. Oops, I should do I comma j in temp. And then just do edges of, or not, yeah, edges of I dot append j. Print edges. Just use this test case that we practiced on. Oh no, we don't have to. Okay, let's see. Negative 23 has 1 and 2. 8 has this. Okay, so we can get our code back up, and then to grab negative 23, we need to do edges of instead of edges of I, it's just going to be edges of the array of I. For j and that, and then it should return the indexes. Yeah, so this is perfect. Hopefully I don't TLE again. If I TLE on this case, it'll be annoying. Okay, looks like I have a solution, but that ran really slowly, so there might be a way to do it. I feel like this is n log n though, right? Because the sort function takes n log n, and then the BFS function should only take a max of n. Oh, other than this case, maybe. If they're all 7s, they're all 7s with 1 11, then we would be exploring a lot of places. Here I'm adding visit of I here. Okay, I think the reason why it's being so inefficient is because we should actually just add it when we insert it. Oops. Dot add of j. Visit dot add of I plus 1. Visit dot add of I minus 1. That way we're guaranteed to not visit it twice. Although I would still be, here I'd be iterating through n. I could, if this doesn't run, I could try to, if j not in visit, then I can try to delete it from my edges. If j not in visit, else, how would I delete j? If I just del j, will it break? I feel like that would break. Okay, I should do edges of this thing of something dot remove j. Cannot call delete. Oops. Oh my god. That's guaranteed to explore every edge once. How did I get the wrong answer here? Let's see. 0 0 1 1. Why isn't it exploring the edges? Oh, wait. Does this actually have that big of an impact on the program? Oh, TLE though. Zero, 0, 4. Yeah, this is like the expected way to traverse the graph. Numbers are very large. Lots of people got the question correct. How do I make this faster? So right now it's going through every single edge and checking if they're in visit. I comma j comma I comma j in the, I can't use I, index in the enumerates. Am I allowed to del it? Oh wait, no, if I visit it, I can just like delete it. Edges of array of I dot remove. Oops. Dot remove of j. Can I do it here? Let me just get rid of this one so I can not TLE and see what happens. Wrong answer or TLE? Wrong answer. Print the edges. We're gonna print the edges here. We start at 0, 0 with 1, 2, and then we jump to 4, 1 with 1, 2 still. How do I remove that term without it doing that? Like, what is going on in between these two? Is it even doing anything? Oops, I meant to do this. Meant to do this. Let's print J as well. Hopefully I don't TLE. I got it. Alternatively, I make it a set and just remove the numbers later. Does removing on set make more sense? 0, 4, and I remove 4 as I do it. Edges of I dot append j. If j is not, okay, I don't need to do that. That's just one small case. 1 and 2, and as I visit, I should do that with here too, right? Or I wouldn't know where to remove it though, because you're not traversing an edge. How is this not just n though? How is this BFS not n? And how am I getting the wrong answer here? We can try to think about if there's a faster way to do it. Is my visit array not working? Or set? Maybe my visit set has some inefficiencies. feel like this should be an n log n solution right here. Where I visit 0, and then I visit 1 and 4, and then I visit 1, 3, which makes sense. And I visit 0, 1, 3, 4, 5, 6, 7. Okay, alternatively, if we get triple of a number, here, this is how we can cut down on that crazy test case. If we have 3 of the here, if I'm already visiting the edges, if I'm already considered all the edges, instead of trying to delete every single edge, couldn't I just delete the entire thing and not need to revisit that? Let's make this an empty list. Does that logic make sense? Okay, obviously it's going to work for these easy test cases. For this one. Invalid test case. How is this invalid? Oh my god. I didn't copy some of it. Okay. Huh? I got it? Okay, so maybe this was just a strat. Maybe I didn't need all of this hard coding here either. Oh my god. I got obliterated by this one. I want to take a screenshot of this. I got obliterated by this one, man. This question was really hard. Or it wasn't hard. It just took me a long time to realize that the edges could actually get... You can actually just remove the edge after doing that to save a lot of runtime. Okay, let's see what other people did. How am I supposed to read this code? There's like so many different sets. Like, how am I supposed to read this code? Okay, give me another one. I can't read that code. Okay, I just looked at that. This guy created a graph or something? Dude, everyone's doing something different. Okay, this person did a BFS. That seems normal. This person definitely did a BFS. Person did a BFS as well and used a hash map. I should have created a visit for, instead of making my visit like based on the index, I should have made the visit based on the something else as well, the numbers. My memory was really bad. Everyone used BFS. Okay. Really fun question, I think. Ooh, there's jump game 6 and 7. Ooh, probably should work on these ones as well. Hopefully you guys enjoyed me struggling on this one. Yeah. And me just like delete all of this and see if it still runs with better memory. And so I feel like this right here is the big idea that I missed in the beginning. Then, well, I tried to implement it, but yeah. Yeah, this is the big idea. Oh, my runtime just got a lot slower. Okay, so like, I guess cheesing it does increase the runtime by a lot. Yeah, so doing the optimizations in the beginning does improve the runtime by a lot. Okay, I think my lead code just lagged out, so it's a good time to end the video. Hopefully you guys enjoyed me struggling through this hard question. And yep, thanks for watching.